Okay, and the difference between water and other liquids, or liquids that turn into solids, let's put it that way. Ice floats in water where others would sink to the bottom. And why does that happen? Okay, because the density of ice is 0.9167. That's question 23 if you're following along. Whereas water itself has a density of 1, so therefore ice floats on top of the water. And water has its maximum density at 4 degrees Celsius. And we know that water freezes at 0 degrees Celsius. Okay? Then the ice becomes less dense. As the molecules slow down, they arrange themselves into honeycomb-shaped crystals that are held together by hydrogen bonds. So now I want you to take your water molecules and arrange them in a honeycomb shape and see how that happens. Okay, number 26. Why is ice floating on water important to life on Earth? Would all aquatic life die if ice didn't float on top of the water? So something to think about. We talked about how water doesn't heat up or cool down very fast. Okay, water also has a high specific heat capacity, also called specific heat. And why is that? Because of hydrogen bonding. What is specific heat? It's the amount of energy needed to raise the temperature of a substance by 1 degree Celsius. Okay, the specific heat of water is 1. Okay. So therefore, it doesn't heat up or cool down fast, unlike a metal that'll heat up really fast or cool down really fast. And that is question 27. All right, and again, why would water have this special property? Once again, its ability to hydrogen bond gives us that special property. All right, and you can see, lucky for me and you, in our fish in the pond, water does indeed have a very high specific heat capacity. The specific heat of water is the amount of heat needed to change water from a solid to a liquid. It doesn't get hot very cold or fast, and therefore it is nice for our little fish in our pond here. Okay, we're going to get out our nonpolar molecule, and you'll see it's gray. It's ethane. So get it out of your little cup there. And you can see ethane. Here's our chemical formula. We've got 2 carbon and 6 hydrogen. So the gray represents the carbon and the white are the hydrogen. Okay, and we're going to figure out, does water and ethane dissolve in each other? So let's take our ethane. And we're going to determine, is ethane polar or is it nonpolar? Look at our structure here. And this goes back to first semester again. Ethane, we have this symmetrical shape here. We have equal sharing around the central atoms. And therefore, this is nonpolar. All right, will ethane form? It should say, will ethane dissolve in water, not form, dissolve in water. Okay, so we're going to try and stick the water and ethane together. So I want you to do that right now. And do they stick together? No, they won't stick together. Because why? Polar and nonpolar will not dissolve in each other. So that's question 30. Okay, now we need our sodium chloride. Let's get that out. Here's a picture of it. What do the colors represent? Okay. And then right here, you've got a sodium and a chlorine atom, and they're going to stick together, and they form sodium chloride, which is an ionic compound. NaCl. All right. So when positive sodium sticks to this negative chlorine, this attraction between the ions is called an ionic bond. All right, ionic bonds in polar molecules. So what happens during dissolving? How is it dissolved? Sodium chloride dissolves in water because the water will surround each ion within the water molecules. Okay, so here on question 32, which end, the hydrogen or the oxygen of the water, is attracted to the sodium, which is the blue magnet, and which end is attracted to the green magnet, which will be our chlorine. Okay, so I want you to try and stick those together. All right, and you can see right here in this picture how water will surround those salt molecules and pull them apart. That's what dissolving is. All right, so sodium ions are positively charged. How we know that? Because we have an ion chart. All right, and chlorine ions are negatively charged. Look at your ion chart. Okay, so now we're going to try and pull apart your sodium and your chlorine. Pull it apart and see how that feels. And now pull two water molecules apart. Is it harder to pull two water molecules apart or the sodium and chlorine apart? Okay, so which is stronger? That ionic bond or the hydrogen bond between the two water molecules? Okay, so it's much harder to pull that sodium and chlorine apart because the ionic bonds are much stronger than the hydrogen bonds. Okay, so ethane's nonpolar. Will sodium or chloride interact with ethane? Okay, so that means would sodium chloride dissolve in a nonpolar liquid like ethane or oil? And no, try and stick them together. See what happens. Will those two stick together? No, we cannot dissolve. Nonpolar compounds do not dissolve nonpolar. I meant nonpolar do not dissolve ionic. That's what I meant to say. Alright, that's what we just tried to do. Okay, water is the universal solvent because it will dissolve all ionic and polar molecules. Alright. Why is it? Because of hydrogen bonding. Okay, let's remember that. Like dissolves like. And you'll see that on the worksheet that you're going to do after this. Alright, number 36. The attraction between two like water molecules is called cohesion. And the attraction between two unlike molecules is adhesion. And you're going to find both of those on your test. 37. Capillary action occurs because water is sticky thanks to the forces of cohesion and adhesion. So try and stick your water molecules together. See how that works? You can do that. So plants and trees couldn't thrive without capillary action. Plants put down roots in the soil which are capable of carrying water from the soil up to the plant. Now try that yourself. And last slide here. We've got hydrophobic, means it repels water, versus hydrophilic, which means that it likes water. Okay, and here are some examples of hydrophobic versus hydrophilic. All right, that's the end. Everything you ever wanted to know about water.